So for our next learning objective, we're sticking in identities. We're not learning any new identities. We're going to just use all of our identities together in order to simplify expressions. All right, so keep in mind, an identity just means a statement that's always true. All right, so I can swap identities with each other, right, because if they're equal, I can just kind of plug one thing in for another. And we can use that to simplify some complex equations or expressions. All right, so for each example, they're going to be a little bit different. We kind of have to figure out what can we use where. Sometimes just an algebra manipulation. Sometimes it's using a trig identity. So here we have sine of x minus cosine of x squared. And keep in mind, squaring something means you're multiplying it by itself. So this is the same as sine of x minus cosine of x times itself. Which means when you do this, you have to FOIL. You can't just put a square on both these things and be done. So when I FOIL, I get sine times sine is sine squared. Sine times negative cosine, and another sine times negative cosine is going to be 2 of those. And a negative cosine times negative cosine gives me positive cosine squared. And that doesn't look any simpler or anything, but if you look at the very first term and the very last term, we have sine squared plus cosine squared, and that is equal to 1. All right, so that's a perfectly fine answer, and that's kind of the answer I would actually expect. All right, one thing you could do if you wanted to be a little crazy is this right-hand side here, 2 sine x cosine x. If you look through all the identities we've learned, we have one that looks just like that, and this would be 1 minus sine of 2x, because that's the double angle identity for sine. I really wouldn't expect that last jump, but you can. All right, this does look simpler than that one. There's less trig functions, or it's less writing. But kind of getting it down to a point where you just have sine and cosine is a pretty good place to get. This is kind of the simplest it's ever going to get using your identities. All right, so for yours, I try to simplify this. -2 sine of negative x cosine of negative x. And here's what I came up with. So the first thing, sine of negative x, we can use our odd identity to kind of bring that negative out in front. Cosine is even, so the negative just goes away. And then these two negatives cancel to give me 2 sine x cosine x. In this case, that's the only thing in the expression. So then, is there any identity that matches that? And yeah, we just used it in the last example. Sine of 2x cosine x is sine of 2x. Right, so we're just using that exact identity from our double angle video. So another thing we can start doing is we have this kind of list of identities. Can we start making new ones that might come up? So we have an identity that we've used a couple times already in this video, sine of 2x. What about sine of 3x? What if I want to figure out 3 times some angle using some formula? Can I do that? And the answer is yeah, pretty much for all these ones you could make an identity. They'll get more and more complicated, and that's why we kind of don't have an infinite number that we're going to remember. The way we could do this with sine of 3x is we don't have anything to do right away with 3x, but I could write it as x plus 2x. And why is that convenient? Well, x plus 2x, we have this sum identity. The sum identity, we take the sine of the first angle, cosine of the second, and we add the cosine of the first angle, the sine of the second. So that's one formula you could leave, or we have formulas for these double angle identities. I'm going to leave the cosine one for a second. And the reason for that is the cosine of 2x, we have 3 different options for what the identity we can use is, versus sine, we only have one option, which is the one we've used a couple times in this video already. So I'm just combining all the terms, and I get that kind of right-hand side is 2 sine x cosine squared of x. All right. So which identity do I want to use for cosine? Well, this one has a cosine squared, and there is one identity for cosine of 2x that also has a cosine squared, and that's the identity, oops, 1 minus 2 cosine squared. Now we can do is distribute this sign in. And this is where I realized I made a mistake because I used the wrong identity. Because it's not 1 minus 2 cosine squared, it's 2 cosine squared minus 1. All right, so I have to erase this one. I realized I made a mistake, so this becomes 2 sine x. It looks similar, but the negative signs aren't the same. So now, with my mistake, these two terms would have canceled out, but now they're going to combine. I'm going to get 4 sine of x cosine squared of x minus sine of x. So definitely more complicated than this double angle identity we used here for sine of 2x. All right, this is the identity for sine of 3x. You're not going to have this one memorized. You're not really going to use it in practice, but it is possible to make these new identities from our old ones. All right, so using a similar pattern, go ahead and try to find cosine of 3x. All right, some formula for that. And this is what I came up with for this one. So again, really similar to the last one. 3x I can rewrite as x plus 2x. Then we use our sum identity for cosine, all right, to get this step. And I'm going to start off with rewriting sine of 2x using that double angle identity, because there's only one thing. And then I notice there's going to be a sine squared because there's 2 sines on that right-hand side. So I used a different identity for cosine of 2x, so I get that sine squared to match. I distribute cosine of x in, and then you can see these two things are similar. I can combine them into one final answer down here, which ends up looking really similar to the sine of 2x formula, which is kind of a good thing that they look similar. But again, you're not going to have to memorize this. You're not going to have to kind of do this in general, creating new identities from old ones. But it does give you an idea of how you can use different identities to your advantage. So we used a sum and difference identity, 2 different double angle identities, and just some algebra of simplifying things to get to this final answer. So for your multiple choice question, all right, simplify sine of x divided by cosine of x. So there's something you should know before doing this video, but kind of a reminder, what is sine of x divided by cosine of x?